Hello, and in today's PIC programming tutorial, I'm going to be covering how to interface with a 2x16 LCD. Now, let's go over the hardware schematic. So I have a 330 ohm resistor connected to the positive of the backlight, and then the backlight is just grounded. And then the data lines of the LCD from D0 is connected to RB0, and then all the way to D7 is connected to RB7. Then my enable is connected to the D port on RD7. My read-write line is connected to RD6, and then my register select is connected to RD5. And then for the contrast adjust, which is V0, I have that connected to a variable resistor, and then the variable resistor is connected in series with another 330 ohm resistor. Now let's go over the datasheet for the LCD. The LCD driver chip itself is a HD44780 chip. Most of the manufacturers don't tell you this, but this is the most common driver chip for LCDs. Now the pins for the LCD, first we start with the RS pin, which is our register select pin, and that pin, when it's 0, it accesses the instruction register, and then when it's high, we access the data register. Then we have our RW pin, which just tells the LCD either we're writing to the LCD or reading from the LCD. Now, most of the time we're just going to be writing to the LCD. And then we have the enable pin. The enable pin is literally just a clock signal to the LCD to tell it we want to get new data from the LCD or we want to write new data to the LCD. Then we have D4 to D7, which is the upper half of the data interface. Now you can just read this for more detailed description on it. And then we have D0 to D3. Now this is the other 4 bits we use for interfacing with the LCD, but when you're using 4-bit operation, these 4 pins are not used. And then we have a bunch of pins we don't use. And then we have V1 to V5, which is equivalent to V0 on the LCD itself. And then we just have VCC and ground, and the rest of the pins are usually connected for us on the LCD. Now, the first things we're going to look at is the basic interface with the LCD. Now, the first thing to note on the LCD is we use the enable pin as our clocking signal, and the data is clocked on the falling edge. So you first need to pull up the enable pin, and then on the falling edge over here, the data is actually clocked into the LCD, or new data is displayed from the LCD. Now RW pin just tells it what we're doing with it, and then our RS line tells us just which register we're talking to. And that's the basics of that. Now the next thing is the instructions we can send to the LCD. Now note we have our RS pin over here and then our RW pin over here. Let me just divide that. Now first instruction we get is clear display with RS0 and RW0, and then D0 is 1. So our clear display function is 0x01 in hexadecimal. Then we have the return home function, which sets the cursor or the display to the original position. So position 00 in the RAM, and that is 1 on DB1, and it does not care what DB0 is, and the rest must be 0. So that translates to 0x02. Then we have entry mode set, which is again with 00 on RW line, and this sets the direction of the cursor if we're incrementing or decrementing the cursor. So basically if we are moving from the back of the RAM to the forward side, or if we're moving from the front 00 to the back of the RAM, which I can't remember the ending address, and if we're display shifting. The last bit sets display shifting, which determines how your text will come out on the LCD. So if if you have display shift enabled, you'll have like say A, B, C in a string, and then it will come out as C, B, A. So the first character that comes out is going to be A, then B, then C. If you have not display shifting, your characters will come out A, B, then C. And the entry mode set is code 0x04. Then we have the display on-off control, which also controls how your cursor on the screen acts. So D will either turn the display on or off, C will tell the cursor to be on or off, and then B will tell the type of cursor you want, if you want an underline cursor or a black bar flashing cursor, and that will be equivalent to 0x08. Then we have cursor display shift. Now cursor display shift moves the cursor and shift display without changing any contents in the DD-RAM, so the display RAM. Depending on what the bit is you set here in display, it can actually move the text on your screen, or it can set the position of the cursor and then the left or right. So this tells it, am I moving the cursor or shifting the cursor left or right on the second one, and its base code is 0x10. Then the next function is function set, which tells the LCD what data length are we going to do, DL, the number of lines we're going to have on the LCD, so either 1 or 2 lines, and then we have the font. Now you can get it in either one of 2 flavors, 5 by 8 dots and then 5 by 10 dots, but I'm going to set it up for 5 by 8 dots. And this one's instruction is going to be 0x20, and then we have the GC RAM address, which is basically the access to the physical character memory, and you can use this for custom characters. And this one's code is going to be 0x40. Then we have set DD-RAM address. Now this is your physical display location on the screen itself. So this tells it which memory address you are going to display at. And this one's code is 0x80. Then we have the read busy flag and address. So this is a way for you to get data from the LCD to tell it which address you are currently at. Now the address here is dependent on which one of these two you have written last to. So if you written to the GC RAM as your last instruction, then this will give you the GC RAM address. And if you set the DD RAM, this will give you the DD RAM address. So you need to track that in code. The RW here is set to 1 so that you can read it back. And then the BF bit is the LCD currently busy with something. Just make a divisor here. Now the next instruction is write data to GC RAM or DD RAM. Now again, like the last time, it depends which one's address you set last is the data you're going to write. So say I wrote the GC RAM address, then I'm going to be writing to the GC RAM's data. And then again, if you wrote to the DD RAM address, then you're going to write to the DD RAM data. Your RS line is 1 for that, so your register select, and then your RW line is 0 because you are writing. And the last instruction is read data from GC or DD RAM. So you also register selecting, take your RW pin, and again, depending on which RAM address you wrote to last, this will determine where you're writing data to. Then we have a table here which gives us all the codes for each thing. So you can look at this table. I'm not going to go through all of them. Then we have instructions descriptions. You can just pause the video and just go through them. Okay, now for initializing the LCD. Now the chip has an automatic initialization as soon as you apply power to it, but in most situations you're going to initialize the LCD anyways in your code. So this is actually necessary for every time your code starts up. So the basic initialization is, so on power on, it waits for the voltage to rise to 2.7 volts. Then you have to wait for 40 milliseconds to initialize the LCD. Then the next thing you do is you send 0x30 to the LCD. And this is for the 8-bit interface. And then you wait another 4.1 milliseconds after you've clocked this data in. I usually wait for more than the stipulated amount of seconds just to guarantee my data is going to get clocked. Then you send another 0x30 to the LCD, and that is on D5 and D4 of the LCD. Then you wait for 100 microseconds, but I'm going to wait for 1 millisecond in the code. And then you finally send your final 0x30. Then you start with the initialization code. So the first command you send to the LCD is function set, which in this case an 8-bit. So this bit, which is D4 DL, is always equals to 1 for an 8-bit interface. And then you send the number of lines and then the font. Then you turn the display off, which is display on off control, as well as the cursor display control. And then you send a clear display command. And then you set the entry mode, where you set if you're incrementing or decrementing the register, then if you're shifting the display. So shifting the display will, in my case, will be 0, because I'm not going to shift the display, and I'm going to increment the display. Now the next thing is how to write to the second line of the LCD. Now if you can see here, the display position is 00 in the DRAM over here, and then on a 16 display 0F is the last address. But when you see here, it can be extended to a 40 output extension driver, which most displays are actually wired for. So your second line will actually start at DDRAM address 40. When you start displaying characters, you'll go all the way from 00 to 0F. Then you need to jump all the way to 40 address to go to the second line. Then something I just forgot to cover. The write data to GC or DDRAM is where your character display will happen. You have to write data to the DDRAM. That will tell the LCD what character to display at the specific position on the screen. Now let's look at the characters that can be printed on the LCD. Okay, now the characters you can display on the LCD is this block of characters you can see here, and actually most of the characters correspond to the ASCII table. So you can just pass in straight characters to the LCD. Aside from some special characters, something to note here is which ROM code you're using on your LCD. Now, I just determined this by just printing out a character that's different on the two ROM codes. And you can see the ROM code here, A00. So mine's ROM code is A00. Yours can be A02, which has all these extra characters in it. You can just simply print out a character with the codes here, which is displayed by the upper 4 bits over here and then the lower 4 bits over here. I'm mostly going to be using just ASCII characters. If you want to print out specific characters, you just write to the DDRAM, which is the character code. So say you want to display the $, you're going to write in your code 0x2 and then 2 as well here. So that covers the internal workings of the LCD. Let's get to the coding. Now the base code is the usual starting code. The UART set as a loopback, so if I enter keys on my keyboard via the USB to serial, that we can print stuff on the LCD. We have these two variables that are volatile char, that contains my char, and then just a bool tell the main loop I have received data. Then we have our 8 MHz clock. We have baud rate. We enable the 2 interrupts for the UART to receive data in the high priority, and then we just have a loopback function. And then in the high priority interrupt, we use the UART receive function, UART char, and our data received flag. Now you can look at how I initialize the UART in one of my previous videos. Now let's get to the LCD. The first thing we start with the LCD, we start defining our pins. So we go hash define, we just call it LCD, and we call it the data line, and that will be lat B. And then our next reference will be also a hash define LCD, and that will be our RS pin, and that will be lat D bits LD5. And we have our next one, which is copy this, which is also connected to the D port, which will be our read write pin, and that will be LD6. And then we copy the next one, and that will be our LCD enable line, and that will be LD7. Then we go to our main loop. We start with tris B is equals to 0x00. So we set the entire B port as outputs, and above that we add tris D bits dot RD5 is equals to 0 to make it an output, and we just copy these lines 3 times, and then we say 6 and 7, and we take our macros. We set the RS line to low, set the RW line also to low, and then our enable is equals to low, and we make lat B equals to 0 or 0x00 to set the entire B port low. Now that our pins are initialized as input and outputs, now the next thing we do is we create a function, and this will be our clocking function to tell the LCD take the data I've given you. So this will be called LCD clock, and it takes void parameters. Then we say LCD underscore EN, which we defined up top as 1. So pull the pin high, and then we delay that. We use the function double underscore delay underscore ms, and then we say 1 millisecond, and we take our LCD enable, and because we're clocking in data on the falling edge, we set our enable as low last, and then we add another 1 millisecond delay underneath that. Now the next function is to send commands to the LCD, so basically the entire block of commands. So we also call that a void function. We call it LCD underscore command. And that takes in a uint 8 as our parameter, and we'll just call that one command. Now, if you're sending a command to LCD, RS will always be low, and the write bit also be low because you're giving it data. Now that these two are set, we can use our LCD data line and just set that equals to the command variable. And then we call our clock function, and then we also delay that by 10 milliseconds just to ensure the command goes in. Then we can start with our next function, which is the initialization of the LCD. So we start with void and we call it LCD underscore init and 8 bits. And that takes void parameters, and by the name you can judge I'm going to initialize it as the 8-bit mode. So we just copy our RW and RS lines. Now the first thing we write is LCD command, and then we pass it, like you can see, 0x30 as the command, and then we repeat that 3 times, and then we add a delay of 50 milliseconds at the start to just ensure that the LCD has powered on. Now we'll have 3 initialize indicator commands. Then the next command will be our set function command, and the set function command we start with 02, and then we start filling in the data we need. So since we are going to be in 8-bit mode, we set the mode always to 3, and then the number of lines to 1, and then the font also to 1. So in this command, that is set function, we set 8-bit mode. Then we set it as a 2-line display, and we set the font to 5x8. And then the command after that is to turn the display off. So we pass 08 as the command, and this will say display off, cursor off, and cursor no blink. And then the command we pass after that is clear display. So literally all this does is clear the display and set to home position. And then the last command in the initialization is to set the entry point of the display. The entry point of the display will be 6 in hex, and this sets the display to increment and no shift. So as you type in data, it will just go ABCD instead of staying at a single position and then just pushing the characters out. And then the last thing, we actually need to turn on the display. So we copy the display command, which is 08 at the moment, and we just turn that to 0f. So our display is on, our cursor is on, and the cursor blinks. Then we take the initialization function and we just place it in our main loop. Then we do another function to actually print data to the display, and we set that as void, say LCD print, and that takes in a uint 8. We'll just call it X. Now to print data to the display, then write data to GC and DDRAM function. So what we need is our RS line, which I'm just going to copy from the LCD init, our RS line as 1, and then our RW line as 0. And then we can just say the LCD data line is equals to the X variable we pass in, which can be any data in the memory map. And then we simply just get our clock function and just call clock at the end. And then the function after that, we want to be able to print strings to the LCD. So we call void, we say LCD print underscore string, and we pass that a const char. We make that a pointer, and we somewhere just call that str. Now we declare a variable in here, which is uint 16 underscore t, and we'll call that I for counter, and then we simply use a do while loop. And then in the do while loop, we take the string pointer, we give it its position in the array of characters, and we take LCD print there and pass the current position of the string pointer to LCD print. And then our string pointer must not equals the termination character of a string. So \0. And that's simply how you print a string to the LCD. Now our final function will be placed above LCD print, and that is going to set the current position of where we're displaying on the LCD, because we have to skip a section of the RAM to get to the second line on the LCD. We start that as a uint8, and we say LCD underscore set pos, which is short for position, and we pass in uint8x and uint8y. Now these are your two coordinates for the LCD. So basically what you say is if y is equivalent to 1, then simply x plus equals 40 hex, which is the first position on the second line of the LCD. And then simply you call command, then the command to write to the RAM, which is set DDRAM address. So we take 0x80, and then we OR that with the current position of X. And now we actually need to modify our print function so it actually keeps track of where we are on the LCD. So we simply just add two static variables to the global scope. POSTRACK will track the number on the X line, and line track will track on which line we are currently on. So we go to LCD print. So I'm quickly going to copy paste that in here. So if POSTRACK is greater than 15, we reset the current X position of the LCD. And then if we have line track greater than 0, the position to 0, 0, so the home position of the LCD, and line track to 0. Otherwise, we increment and we set it to the first position on the second line of the LCD. Then we take POSTRACK, simply implement that after we clocked in our data. Okay, now let's actually print something to the LCD. Then we take LCD print string. We place that after our program has started, and we simply say this is a string, and that actually fits exactly on the first line of the LCD. And then we can take the print function and place that in our while loop after we received data from the UART. We simply take the data we received from the UART and print that out on the LCD. So you will be able to see what I'm typing on the keyboard via the UART and then also on the LCD. Let's give that a quick compile. I see an error that a non-void function is not returning. Just simply here, all you do is we add return X, so that we have a way to track our current position or find out what our current position is on the LCD. And apparently I forgot to add my string counter. We just add to our print string function a ++, and we just reprogram the PIC. Now as you can see, we have, this is a string printed out on the LCD itself. Now when I actually type to the UART, we can see that we have characters going out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. We add a 0. Just to fill up the line, and then I can clear the LCD by pressing space, and we can see the cursors blinking and flashing to where we are writing now. So now that the LCD is clear, we can go subscribe and like the video, and you can see it automatically runs over 2 lines as I type in data to the UART. So that's an introduction to using a 16:2 LCD display with a HD44780 driver. If there's anything you would like to see, please let me know down in the comments. The code will be linked on Git. Thank you. Have a nice day.